Hi and welcome to another MoTeC webinar. My name's Pete Swinney and today's subject is ECU initial setup, ignition and injectors and outputs on the M130 GP Lite ECU package. Okay, we'll start with ignition. That's relatively simple. So I'll just flip to the live screen to show you where we are. Okay, so we're going to be over on the initial setup workbook and in the ignition configuration worksheet. Let me just fix my simulator. Alright, so this is where we're working today, and we're going to go to injectors over here and then outputs over here on this worksheet. Alright, so only a couple of parameters to sort out really for the coils. So this page is really dedicated to just setting up your coil, testing your ignition coils, and doing the reference offset, which is the old CRIP test from the gold box iteration. Alright, so the ignition coils, most of the time you'll be choosing manual here and just simply entering in what we call charge time in the M1, used to be dwell in the M84 gold box series, and then whether it's rising or falling edge. So for 95-96% of all ignition modules out there, it's a falling edge trigger. The rare exceptions to that are some Hondas, some early-ish Hondas, and MSD run rising edge trigger. You'll need to know what your particular ignition system edge triggering point is, and make sure you enter that there. Right, so you can see we're highlighted on the charge time main table here, and you fill out the charge time for the appropriate voltage. So you get that information from us. Send us the coil if we haven't already got it done, or you're transferring that information up from an earlier file off a gold box perhaps. Okay, and perhaps one of the biggest things that you're going to be in this page for, other than the initial setup of the coil, is either for testing or for setting the CRIP or the reference offset. So that's the highlighted box we've got here. So here's an exploded view of it. So here we have the engine speed reference offset number. This is the number that you'll change to get the timing light to flash at your ignition test timing point. So in this case here, it's at 0 degrees. Alright, and to put it into the mode to do that check, you select this drop down here and you go into check timing mode. So I'm just going to flick across to the live software, it's a bit easier. Alright, so on this package here we've got our engine speed reference offset is 88 degrees. In this particular case we are not in check timing mode at the moment, so you can see our ignition test. If we have a look at our options, we can go into check timing mode. We can cut in a whole bank of a cylinder, so if you have a V8 you can cut all of one side. That's more a fuel film tuning thing. Or you can cut individual cylinders, which is kind of good if you're looking for a cylinder that's weak, down in compression, something like that. Alright, but for the purposes of what we're going to talk about today, we want to put this into check timing mode. Okay, once we do that, you'll see the ignition timing state now is in check timing mode. If you have a look across here, ignition timing dropped back to 0. Alright, that's what the ECU is expecting to see, or what you need to line up on the timing light that would be 0. So for example, if I made this 10 degrees, you can see now the ignition timing is solid at 10. Right, so if I rev the engine, no matter what, the timing should stay at 10 degrees. Okay. Alright, so most or a lot of engines just have a top dead center mark, so let's go with that reality. So while you're in this mode, the ECU will keep the timing at this number, and you see that again the ignition timing state is in check timing, and you get your timing light out and make sure the mark lines up at 0. If it doesn't, you basically change this number up and down until it lines up. Maybe you've got to alter at 10 degrees or something like that. Do what you must with this number to get the light to line up at 0 degrees on the engine. Okay. Now the thing with this, to be very careful about this, if you get distracted and move off to another screen, you know, you need to go and do another job somewhere, come back, start the car again. If you've saved the file like this, this doesn't go out of check timing mode unless you physically force it to. So that can be a trap, whereas in the gold box series, M84s, M800s, when you went out of this particular screen, it automatically clicked out. The M1 doesn't, so that's something to be very careful of. Alright, so when you want to check your reference offset or your crib, you go into check timing mode. As soon as you're done with that, click back out again. Alright, so just covering off those few things. So we've got our ignition coil calibration. If your coil is listed here, obviously you can just choose that, and then that does the charge time for you. Most of the time you'll be on manual setting. There's your charge time table or your dwell time table, and then you can choose rising or falling edge. Quite simple. Now if you want to test your coils are working, which is a good idea before you start your engine, you can choose this drop down here whether you're choosing fuel or ignition. So if I wanted to test ignition, at this point here the coil would be operating at 4,000 revs and we'd be on cylinder 2. We go cylinder 1, cylinder 3, whichever cylinder you want to test. Alright, and then when I want to stop working, I disable. Okay, that's pretty simple. That's ignition. Most of that covered off. Alright, injectors, a little bit more to this. So the M1 really does rely, if you want the best from it, then it's a great idea to get as accurate an injector calibration as you can. Everything will line up nicely. Your efficiency numbers will be quite realistic. The lambda will follow its aim really well, even without closed loop. There's lots of advantages to running, lots of advantage in tuning with really good injector calibrations. Basically, if the ECU knows exactly how to get a certain volume of fuel, then when it delivers that fuel, if the lambda is wrong, it's not the amount of fuel that was delivered that's wrong, it's its calibration of the amount of air that was going in, which is the efficiency table. So if we put in a very accurate injector calibration, this gives us really nice and normal engine efficiency numbers, and effectively you can take a map from a jet ski, a Nissan Patrol, 2J, anything. They're all going to be relatively similar because they're all just 4-stroke engines with similar efficiency. So if the injector calibration isn't accurate, it's not the end of the world. It just means your numbers and your efficiency maps aren't going to be similar. So in an ideal world, you can just choose from our drop down the injector that you've got, and that's 90% of the work done. So in the case here, we've got some Siemens Deckers. These are the 2300s that a lot of people use for methanol. So you just simply click this drop down and go through the list. We've done plenty of injectors now, and so you can go through the list and select the injector that you've got. If it's not in the list, you can contact your dealer or MoTeC and see if it has been done. Sometimes injectors get done and haven't made it to the list yet. That takes a little bit of time. So quite often your injector has already been done and we can just give you the calibration for it. And then sometimes it hasn't been done at all, and if that's the case, you can, through your dealer, send the injector to any of our major offices, USA or UK or here, and we can get that injector calibration done. Alright, and then once it's done, we can just give you a single file and you can load it in, and it gives the ECU all the information it needs to know how to get a precise volume of fuel. Makes a big difference. Alright, so scenario 1 where the injector's there, it really is quite simple to load that. Let's go back across to the live screen, it's much easier. Okay, so we're going across to our injector setup page, and we'll just click back to a well, we can go for that Siemens Decker or anything injector. ID 1700s, where are they? They're not here. Yes, they are. There we go. So these are the Injector Dynamics 1700s, which are quite popular now. Alright, so as you can see, two things have happened. One, all the setup's now gone because that's all included in the calibration, so you don't need to worry about peak and holds or saturated or minimum volumes or anything. It's all gone away because it's all contained in this calibration. Alright, you'll also see that because this is a major setup item, the ECU wants to do a full reset. That's why it's gone red. And so we'll do that. So Control S, or you can press the little button up there. So it's going to do a full reset now. So it goes offline for just a little second, and now we're back online. Alright, so really that's it for the injector cals if your injector is known. So as soon as you look like you're going to be doing a tune on your engine, that's one of the very first things to identify that which injector you're using and see if it's in our database. If not, contact MoTeC, see if it's in the database but hasn't made it to the software yet. And if it hasn't, then send the injector to your nearest dealer to get the calibration done, and we do that. That costs nothing, provided it's an unmodified injector. Alright, so let's look at the manual ways of doing it. So if you don't, for some reason you're under pressure, you want to get the job done, you haven't either got time to send us the injector or you don't have it, so you can go to manual. And this is just the same is pretty much the same as any other ECU. You're going to have to work out for yourself how to drive that injector. I mean, if you've got it from the manufacturer, that he will tell you if it's a peak and hold injector or a saturated injector, these key values. So the 1700, because we clicked on there, the calibration for that ID 1700 is now displayed here, and you can see it's a saturated injector. But if you're running a peak and hold injector, then you can enter that, and it might be something like a 6 amp peak and maybe a 1.5 amp hold. You need to understand what these settings are. We can't tell you if you don't send the injector to us. And then the other piece of information that's quite important is the reference flow. So what that means is how much fuel does this actually flow, and you also get to put in the pressure that test comes from. So let's just put down, say this, you make even if you do a manual measurement of this is actually reasonable to do this. So you can manually flow this injector yourself, and you might set the test up at 60 pound of boost, and you find that it flows 2 liters per minute. So in other words, it might flow 1 liter in 30 seconds. Right, so if you can get that accurate, it makes quite a big difference to the accuracy of how the whole setup will work up in the area where it matters under power. So quite a simple test or information that's easily obtained from the manufacturer when you buy your particular set of injectors. So that is worth the time getting that right. And then if you've got your what's effectively dead times, or these are the volumes of fuel that are flowed in the non-linear area. There's a screen coming up to explain that. So this is a 3-dimensional or a 3-axis table. So we have fuel pressure on our vertical axis here, the actual volume across on the horizontal, and then the time to get that volume. So for example, if the ECU calculates that it wants 55 microliters of fuel, and it looks at the fuel pressure and says, well, I'm at 5 bar, 500 kPa fuel pressure here, then at 10 volts, which is the table we're on here, it knows it needs to open for 3.344 milliseconds. Alright, so as the voltage goes up, of course the injector operates quicker, so we can see there's a different table for each voltage. Alright, so these tables are to cover what's called the non-linear area of the injector's operation. So that's right down the bottom, and depending on the size of the injector, you can think of that as being around the sort of idle to cruising down the road at 60 kilometers per hour, 30 mile an hour. But if it's a big injector, that might even be up to 60 mile an hour or 100 kilometers per hour. So So this is the non-linear area of the injector, and if these aren't accurate, then you just don't get repeatable and accurate fuel calculations for any requested fuel that the M1 just calculates it needs. Now, if you're racing and you're running up in the linear area of the injector, up towards 3/4 of its flow, anywhere around there, then what the ECU is using is this reference flow point. It's using a lot more of that to decide the actual volume that it wants, or to decide the pulse width. Right, so that's why if it's important to you to it's a racing car, it's running 2 bar of boost and it's all about racing, then this reference flow is really worth getting right. Okay, but if you're trying to pass emissions and do something like that, then all the starting and the drivability and the round town stuff is really important to you, then you really need to get the injector flowed and get all these tables done properly. Okay, all right, but ultimately, if the best way, of course, is just supply us the number and see if the calibration's here, and then just choose the one you want, and then it all gets done in the background. All right, so what else are we doing on the screen? This is how you test your injectors. Obviously, you can test your injectors over on the ignition screen. It's the same output test here, so we can choose to test our fuel primary, and we've got an output diagnostic here that pops up that says we've got an open fault with our injector, because it knows we're trying to run it, and because I've got the simulator running here and there's no load across the injector outputs, the ECU automatically detects that. Alright, so basically we can set the ECU up to test at any speed we want. So here the injectors will be operating on cylinder number 3 at 1000 RPM. So we can just go around all our injectors and make sure they're all working. Obviously, if this is the first time you're setting up and doing this, you want to do the coil testing first, and you really don't want any fuel pressure in the rail, so you want your fuel pump disconnected. Alright, once you're done testing your injectors, you just go back to disabled and you're all good. Okay, let's pop back to the presentation. Okay, you can import calibrations manually, so there's a couple of ways to do that. I'll cover that off in a minute. We've done the rest on this page. This will just cover off what we spoke about here, how we've got injector cals and what these tables are for. And one of the big advantages is if you set this up, which I didn't cover, if you do have the correct injector in and loaded into the ECU, and you do a tune, the car's running great, and you might find the customer wants to put on a larger turbo and you're out of injector. So if you need to step up in injectors and you choose another known injector and you choose its calibration, then the engine will run just the same. You don't actually need to retune anything, because the ECU has been putting in a known accurate amount of fuel for the first tune, and if you put in an accurate injector calibration for the second tune with the larger injector, then you'll almost have nothing to do. It'll be very, very close from the outset, and that's a really nice advantage for guys who are stepping up on the injectors. It's actually the same with the fuel type. You can tune an engine on, in fact we did one last week, tuned it on 98, changed it over to E85. It's not that uncommon to do that. We just selected the E85 fuel and engine just started and ran straight away. Some minor changes, but you could just about race it on just changing the parameter alone and the fuel. No need to fully retune the thing. Certainly need a look to make sure everything's okay, but we've got all these tools here to make your life easy, so do your best to make the most of it. Alright, so this is a picture of what I was referring to with how all injectors right down where they start to open are non-linear. So this picture here, we've got flow on the vertical axis and time. So if you have a look, we have a certain amount of time that occurs and we don't get any flow on an injector. And then once it does start to open, the flow starts to come up quite quickly. But depending on the voltage and pressure, there's a stage of most injectors where you open it for longer and it either doesn't increase its flow or the flow goes down. So you can see here in this area here, we're opening it for longer, but the flow is actually going down. So if the ECU doesn't know about this characteristic, then when it wants a little bit more fuel, all right, and it goes to add a little bit of time to the pulse widths to get a little bit more fuel, and less fuel flows, then of course that doesn't make sense and you get lambda readings that are inconsistent. So this happens in the first sort of 2 or 3 milliseconds of every injector's operation. After that, you pop out of that area, it becomes linear. So basically, the longer you open it for, the more the flow. And so if we characterize this bottom area with those linearization tables, and then we do one other test to find out what the maximum flow rate is at a certain pressure, we can then predict, without having to measure it accurately, if we have any particular type of fuel volume amount, we know the time required to get it. So I mean, this means that we're getting accurate fuel delivery, we're not relying on closed loop, and the whole fueling of the engine is just so much better utilizing a proper injector model. Alright, so we just go back again. Just wanted to make sure we covered off all of that. Go back to manual. Yep. Alright, so that's pretty much injectors, and yeah, get the information in there and you'll get a good result at the end. Okay, so moving to outputs. So your outputs are over here. There's a panel for each output that's configurable on a GP Lite package, and if the output's not allocated to a resource, then the setup, it doesn't appear. So if you go to the page and it all looks black and you go, oh, I want to set up a coolant fan, and you can't see any of the setup, what that will mean is that you haven't allocated it to a resource. So I'll just quickly show you how to do that. We've covered that in a previous webinar. We'll just press Control S and get rid of this reset from changing all that injector stuff. Okay, and the way I allocate resources is to go Tools, Edit, Input, Output, Resources, and we type the output that we're after. So maybe it's a coolant pump, and if we allocate it to any of our available outputs to drive that, and then the setup will arrive. So here you can see we've got our coolant fan is already allocated to low side injector 1, so that's why the setup will be there for that. Here's our coolant fan. Okay, and our second fuel pump, it wasn't allocated, so you can't see anything in the setup there. Okay, the other place that you can configure your I/O or your resources is across on the worksheet 2 here, and here's a list of the resources here. Alright, so you can allocate a brake switch, any available input, just click the one you want. Okay, back to outputs. Alright, so each output's got a different setup. So a typical one is a fuel pump, of course, and this is pretty much the same for all ECUs. We can put on our prime time and hold time. So prime time is when you turn the key on. In this case, it will go for 3 seconds. And after the engine stops, it will hold for 1 second. Alright, just type in the number. And depending on how you've got your relay configured, maybe you've got a relay where there is a permanent ground to the bottom or the trigger side of the relay, in which case you need to supply it 12 volts when you want the fuel pump to go. So if that's the case, then you want to high side drive it. Okay, so that means when the ECU now knows when the fuel pump's supposed to be on, it should go from low to high, as in from ground to driving 12 volts to turn the relay on. Most people wire those relays there where they've got 12 volts to the one side of the triggering coil, and the ECU just takes that to ground to turn the coil on, to turn the relay on, which turns the pump on. Alright, similar for your coolant fans, things like that. Now, if you want to test your fuel pump, that's in this setup here, and you can go to enabled, and this should turn the relay on, and the fuel pump will operate. Alright, another thing worth mentioning, auxiliary output setup. So we've got some typical parameters. They're a little bit different from Gold Box, but you should be able to recognize them. So we have our test duty cycle and our test to be able to turn on and off. We have our polarity, which is meaning 100 in the table is either grounded or 100 is not grounded or high side. We can run the auxiliary output at a frequency. So if you're trying to drive some sort of frequency based fan or injectors or something like that from a table, which isn't what we'd normally recommend, but you're able to drive that at a certain frequency. We've got a normal, our table itself for controlling something. In this particular case, it looks like someone's controlling a solenoid for a VVT solenoid on a, not VVT, just a switch solenoid on this Nissan engine. Okay, and you've got throttle position on your vertical axis and engine speed on the horizontal, and anywhere where you put a number above 51, that will turn this on. If your frequency is set to 0, that's basically switched mode, and anywhere above 51 will turn it from off to on. Okay, and there's another parameter here, an activate. And so what this means is that this table will not be active unless the inlet manifold pressure is above 90 kPa, which isn't really appropriate for this engine. We could make that something like 30, and it's got to be under the maximum, so somewhere between 30 and 500 kPa. As long as the manifold pressure is in this region, then this duty cycle table will become active. The other thing we have on this auxiliary table is we can actually add and subtract fuel depending on what the number is. So for example, if in this table we have an output of 100% duty, and if you have a look over here, whenever the output of the duty cycle is 100, we can do something with our ignition timing. So in this case it was -2. Alright, and same here with fuel, we can add or subtract fuel. So in the case of a switched cam, you could actually do a strategy where if for some reason the cam, you don't wish to switch it, or if you're moving, most of the time you choose your switching of your cam and then you tune your efficiency map. But for whatever reason, if you do want to add or subtract fuel proportional to what the duty cycle here on your augs table is, I don't know what you've got this connected to, this gives you the ability to take timing out or add timing, take fuel out or add fuel. Okay, pretty basic. Alright, that's pretty much it. Okay, bear with me. I don't think we've got any other screens. No, that's it for this webinar. Thanks for listening, and we'll catch you on the next GP Lite webinar.